Hello everyone. My name is Shreyas Kumar and I'm from Sri Venkateswara College of Engineering. I belong to the branch of data science, and the topic of today's presentation is pumping lemma theorem and an example problem to explain it. So let's begin with the title slide. The, it will the presentation will cover introduction to pumping lemma theorem, understanding the context of formal languages and automata theory. It will also cover a example problem which will help understand the pumping lemma theorem even better. The pumping lemma is a property of regular languages. It provides a method to prove that certain languages are not regular. The lemma asserts that all sufficiently long strings in a regular language can be pumped. Pumping for regular set. The theorem states that let L be a regular set. Then there exists a constant n such that for every string w in the language L in the language L, the length of L is greater than or equal to is lesser than or equal to n. We can break w into three strings. W is equals to xyz such that the length of y is greater than 0. The length of xy is lesser than or equal to n for all k is greater than or equal to 0. The string xy bar k z is also in L. Note such k select k such that the resulting string is not in L. Formal statements of the theorem. For any language, regular language L, there exists a pumping length P. Any string S in L of any string S in L of length at least P can be divided into three parts. The parts are S is equals to XYZ, where X the length of XY is lesser than or equal to P and the length of Y is greater than 0, allowing for repetitions. Understanding the components. So the string can be divided into three segments X, Y, and Z. The segment Y must contain at least one character and can be pumped. Pumping means repeating Y any number of times, including 0. Why is pumping lemma theorem important? So the pumping lemma theorem is important because it helps identify non-regular languages through proof of contradiction. The lemma is essential for theoretical computer science and automata theory. It provides insights into the limitations of regular expressions and finite automata. An example of a non-regular language. Consider the language L is equals to a bar n b bar n such that n is greater than or equal to 0. This language consists of strings with equal numbers of a's followed by b's. We will prove that L is not a regular language using pumping lemma theorem. Assuming L is regular. So for assuming L, so for contradiction, let's assume that L is regular. By pumping lemma, there exists a pumping length p. We will choose a specific string s in L that meets the length requirement. Choosing a string S. Let us choose the string S is equals to A bar P and B bar P, which is in L. The length of S is equals to 2P, which is greater than P. According to the lemma, we can split S into parts X, Y, and Z. Now splitting the string, we can divide S as S is equals to XYZ, where XY where the length of xy is lesser than or equal to p and the length of y is greater than 0. Since length of xy is greater than or equal to p, Both x and y consist solely of a's. This means we can express y as y is equals to a power k, or some k is equals to k is greater than 0. We will pump the string by repeating y. If if we let I be the number of times we repeat y, we get the string a to the power of p plus ik and b to the power of p. For I is equals to 2, the string becomes a to the power of p plus k, b to the power of p, which is not in L if k is greater than 0. So the contradiction is achieved. The pumped string a to the power p plus k, b to the power p has more a's than b's. This string cannot belong to L, violating the definition of L. Therefore, our assumption that L is regular must be false. So the summary of example is we demonstrated that L a to the power n b to the power n such that n is greater than or equal to 0 is not regular. The pumping lemma theorem was essential in reaching this conclusion. This example illustrates the utility of the lemma in language theory. So the applications of pumping lemma. The pumping lemma is widely used to prove non-regularity. It serves as a foundational tool in theoretical computer science. Understanding the lemma enhances comprehension of formal languages. Limitations of the pumping lemma. The lemma applies only the regular languages, not context-free or others. It cannot be used to prove that a language is regular, only non-regular. Other methods are needed to analyze context-free languages and beyond. So in conclusion, I would like to say that the pumping lemma is a cornerstone of automata theory. It provides a systematic way to demonstrate the non-regularity of languages. A solid grasp of the lemma enriches our understanding of formal languages. So feel free to use this presentation to outline and to create your slide presentation. Thank you for watching the video till the end. Like and share the video and subscribe to the channel if you want more contents like this.